So let us move on to concept 3. Anyway, the concept as somebody was talking about, it is the idea of successive change, right? Successive change could mean increase, decrease, successive increases, an increase on increase, or a decrease on decrease, or an increase on a decrease, or a decrease on an increase, anything, right? And it could be applied to more than 2 also. So let us start off with a very basic example. Okay, let us start off with a very basic example. For example, let's say there is a number called 150. Okay, suppose I increment this number by 20%. Okay, what does the new number become? We already know that the new number will be 120% of itself, right? 120% means 6 by 5. So the new number will be 180. Correct? Now, if I further increase it by 10%, okay, if I further increase it by 10%, I know that the new number is 198. The idea of successive change helps us in finding what is the equivalent change between 150 and 198. Now this process could go on for n number of increases or decreases, but let's just restrict ourselves to 2 first. So from 158 to 198, what's the change? The change is this: final minus initial upon initial into 100, right? Which is 48 into 2 by 3, which is 32%, right? This is how you do it in a very basic way. There's no harm in doing. If the numbers are very simple, it's probably worth using this method itself, right? You don't need to go for any short. Now, there is a very nice and elegant formula that helps you determine this, right? So if there is a change of A% followed by B%, right? Followed by B%. Now I'm writing change because change could be positive or negative also, right? A negative change would mean a decrease, a positive change would mean an increase, right? Now, then if there is a change of A followed by a change of B, equivalent change, and mind you, this formula is valid only for 2 successive changes, right? Right now we're discussing only 2 successive changes. Equivalent change in percent is A plus B plus AB by 100. Okay. Now, an important thing to note: whenever it's an increase, you will write A as positive. If both A and B are increases, both A and B will be positive. If both are decreases, then you will write minus A and minus B in this formula, right? So replace A or B or both with minus A and minus B, depending on which is a decrease, right? And use this formula as is. So in this case, for example, A was plus 20 and B was plus 10. So what we have is 12 plus 10 plus 20 into 10, 20 plus 10 plus 20 into 10 upon 100%, right? Which is 32%, which is what we got here also. Okay. So this is how you can apply the concept of successive change. Very useful, very applicable in compound interest problems also, right? Because that's how compound interest works. You get some interest, then you get some other interest. Of course, these two quantities, these two increments will be same. You'll not have 2 different increments there. Yes, Garrick, as we'll just discuss another example of positive followed by negative. But the idea that I told you is that wherever you see a negative quantity, which is a decrease, you substitute A or B, whichever is negative, with minus A or minus B accordingly, right? But first, let me know if this part is clear or not. If it is more than 2, we'll see how we can use it. And if you're using multiplying factor concept, then as I said, if the numbers are very simple, then you don't need this method. Then you don't need this shortcut anyway. But if the numbers become complex, then using any multiplication will be sort of difficult. right? Then you can directly use this, because if increases are like this, 13.3 and 12.2, then adding 13.3 and 12.2 is simpler rather than doing 1.133 into 1.122, right? And anyway, in such cases, you'll be asked about a very approximate number, right? So in this case, you can simply say that it is 13 plus 12 plus 13 into 12. Now 13 into 12 is very easy to do. It's 156. So these answers should be somewhere close to 27.5%, right?